Alright, let's say we are given a function, okay? Something like fx equal to 3 minus 2x divided by x. Then we are required to sketch a graph of this function. So how do we do that? Okay, let's go through the procedures of sketching a graph. Okay, the first step is to get the x-intercept and y-intercept. So look at question A. So you need to find the x-intercept and y-intercept. So if you are trying to get the x-intercept, so you just let y equals to 0. Let y equals to 0. So if y equals to 0, but in this graph right here, your y is basically this fx. So what we need to do now is just let your y equals to 0 and then you copy the function back. 3 minus 2x plus with 4x plus 4 as the denominator. You need to multiply both sides with x plus 4. X plus 4. This is what we call the cross multiplication. Then we can cancel out this denominator, and for the left hand side, x plus 4 multiplied with 0, you will eventually get 0. And then 3 minus 2x, now you just bring this negative 2x to the left hand side, and then you just solve for the x, 3 over 2, and this is equivalent to 1.5. Now we have got our x-intercept, so the second one is to get the y-intercept. So for y-intercept, we let our x becomes 0. So your equation will be y equals to 3 minus 2 multiplied with 0 divided by 0 plus 4. So 2 multiplied with 0, you get 0. 3 over 4. So your y-intercept is 3 over 4, or in decimal notation, it is 0.75. 0.75. So your x-intercept is 1.5, y-intercept is 0.75. So we have solved for question A right here. Now let's look at the second part of this procedure, which is the vertical asymptote and horizontal asymptote. So now our objective is to find the vertical asymptote. So vertical asymptote is the line that will approach, but it never touches that line. So that is what we call asymptote. Now, in order to find the vertical asymptote, you need to let the denominator, okay, denominator of this graph, in this case it is x plus 4, let the denominator x plus 4 equals to 0. Then you solve for the x, you get x equal to negative 4. Step, okay, now your next step is to get the limit, okay, to get the limit of this function as our x approaches negative 4. So this is how we write it. Limit of this function as x approaches negative 4 from the left. Okay, we need to do it from both sides, so we start off with from the left hand side for this function 3 minus 2x divided by x plus 4. So what does it mean by approaching negative 4 from the left hand side? Let me show you a simple number line right here. So to the left hand side it will be negative 5, and to the right hand side of negative 4 is negative 3. So coming towards negative 4 from the left hand side looks something like this arrow. And this arrow implies that you are approaching negative 4 from a more negative region. So basically coming from negative 5 all the way to negative 4. So we can come up with a test value of negative 4.01, meaning that this is a more negative value compared to negative 4. So if you are getting closer and closer to negative 4, there will be more 0 after the decimal place, something like negative 4.000001. So this is even more closer to negative 4, and it is coming from the left hand side. But let's just use this negative 4.01 as our test value. So we substitute the value of negative 4.01 divided by negative 4.01 plus 4, negative 1102, okay, 1102. But what if your value keeps on getting closer and closer to negative 4? This value right here will be even bigger than this. Okay, the value will be more negative. The negative value will increase, right? So we are essentially reaching the point where we can say we are approaching negative infinity. So if you're coming from the right hand side, means that you are coming from a region that has a lower negativity value compared to negative 4. So let's just use test value of 3.999 or 3.99. So 3 minus 2 multiplied with 3.99 divided by negative 3.99 plus 4. you'll get a positive value. Meaning that if you go closer and closer and closer to negative 4 from the right hand side, the value that you're going to get is becoming more positive, bigger positive value. So we can say that it is approaching positive infinity. Now let's move on to question C. Okay, find the intervals where fx is increasing or decreasing. So we need to get the derivative of fx, and then we need to let the f prime x equal to 0. So our fx is 3 minus 2x divided by x plus 4, and the derivative for this function will be negative 11 over x plus 4 squared. Okay, we did this through this quotient rule. That is how you get the derivative of a fraction. And we need to let f prime x equals to 0. So what we have here is a fraction. Okay, the problem with this type of function is that we cannot have our denominator as 0, right? But we can still evaluate the content of this equation, okay, which is the denominator part only. The x plus 4 can be solved using this method. So x plus 4 equals to 0, then you get the value of x, which is negative 4. So that is how you get the x value from the derivative of fx. Basically, this negative 4 is the same like your y-intercept, the x-intercept above. Okay, since you're not the x-intercept, since you're vertical, okay, vertical asymptote is also negative 4. Now, what you need to do with this value of negative 4? Okay, from here you can draw a critical line. Okay, we call this critical line. Okay, since you only have one critical number, critical value, which is negative 4, meaning that you have two separate intervals. Okay, the first interval will be coming from negative infinity, and the second interval is going towards positive infinity. So you mark it this way. So your first interval will be from negative infinity to positive, from negative infinity to negative 4. So from negative 4 to positive infinity is your second interval. Then you need to draw a simple table. It's not graph yet. Okay, this is your table. Okay, for this table, you need to create a 3x3 table, and the first column will be intervals, the second column will be test value, and the third table is a sign of f prime x. Okay, because you need to substitute your test value afterward into this function f prime x. So looking at our first interval, which is negative infinity to negative 4, and the second interval is from negative 4 to positive infinity. So your test value for the first part right here, it could be negative 10, and the second test value could be 0. So if you substitute these test values into the derivative function, you will get negative for both. So what does it do then? Okay, well, why do we need to find this sign of f prime x? So this sign of f prime x will determine, this is to determine the increase and decrease interval. So from this table, we can conclude that our increase interval does not exist. Okay, since there are no plus sign in this output. Okay, we only got negative sign, and that negative sign is basically telling you that they are decreasing. So decreasing interval will be both the negative infinity to negative 4 union with negative 4 to positive infinity. So now let's move on to the next part, which is to find the interval where fx is concave up or down. So in order to get the concave up or down, so our f prime x is negative 11, and I bring the denominator to the top, then we need to change the power right here to negative 2. So the f prime x will be 22 x plus 4 negative 3. So the same goes to this part right here. You have got 22 divided by x plus 4 to the power of 3 equals to 0. Since this is a fraction and with denominator of x, so this basically you cannot do anything to factorize to get the value of x, other than you just get this equation x plus 4 and let it equals to 0. So let x plus 4 equals to 0, then your x will be negative 4 as well. So basically you're getting the value of your asymptote. Your x value will always be the asymptote. And now let's draw a critical line. So this is your negative 4, and you have got two intervals. This is what we call critical line. We focus on f prime prime x. But the interval is still the same from negative 4 to positive infinity, and the test value can also be the same. But this time, if we substitute negative 10, you get negative value, but if we substitute 0, you get positive value. Meaning that from here, we can say that our graph will concave up when the interval is from negative infinity to positive infinity, and the graph is concaving down. Concaving down when the interval is from negative infinity to negative 4. So I guess we have collected all the required information in order to solve for this graph. Okay, in order to sketch this graph, we have got all the required information. So sketch the graph of fx using the above information. So let's look back at what we have got. So the first one is your x-intercept and y-intercept. So x-intercept is 1.5 and y-intercept is 0.75. So let me write it again over here. So x-intercept equals to 1.5. Y-intercept is 0.75. And what else? We have got our vertical asymptote. So vertical asymptote, which is our x equals to negative 4. Okay, in order to get the horizontal asymptote, so now what we need to do is to just get the limit of this function as x approaches negative and positive infinity. So to solve this limit, if we substitute infinity is either positive or negative infinity, you get infinity over infinity for this question, or negative infinity over negative infinity. So you don't want that to happen. Means that you need to divide all the x with the highest power of your denominator. So x plus 4 divided by x, then 3 over positive or infinity or negative infinity will become 0. So this x cancel out. This will be 1, and this part right here is 0. So you will get limit of x approaching positive or negative infinity of negative 2 over 1. So if we solve for this limit, you will get negative 2. Therefore, your horizontal asymptote, okay, which is your y-axis, is equal to negative. So that is the other information that we need in order to draw this graph. So let's copy this information and bring it down here, and we get the increasing and decreasing as well. Therefore, these are all the information that we need. So we can start sketching our graph now. So let me pick a line right here. So the first thing that you need to draw is the y-axis and x-axis, because that is the easiest one to do. So let's label this as our y-axis, and let's label this as our x-axis. And you draw the asymptote first. Okay, you draw the asymptote. Okay, let me label my y and x-axis. Okay, I'll use this as 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, for the scaling itself, you just look at the asymptote value. So for my y, the horizontal asymptote is -2, so you can just make it until -3, so you don't have to go very far down. And for my vertical asymptote, it is x -4, so I need to label my x-axis as well. So for my x-axis, get -1, -2, -3, -4, -5. So let me label it properly. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. So this is -1, -2, -3, -4, -5. So for the horizontal asymptote, it is located at y equals to -2. So I need to draw a dotted line right here. Dotted line. And then for my vertical asymptote, it is x equal to -4. So this is my vertical asymptote. Vertical asymptote. This is horizontal asymptote. Okay, some part of this graph will intercept this 1.5 of the x-axis, and it will intercept the 0.5 at the y-axis. So let's let's try to find where is our 1.5 and 0.5 in this graph. Let me draw another axis right here, another labeling. So this is my x equal to 1, x equal to 2, and this is our x equal to 1.5. So this is 1.5. And for my y, it is 0.5. So 0.75 is estimated to be somewhere around here, 0.75. So this will be our second intercept. So from there, you can basically draw the graph right now. So we're going from this positive infinity, and we intercept 1.5, and then we intercept 0.5, then you just go all the way up. And is this the correct pattern for this graph? So look at the concavity. This part right here is actually from -4 to positive infinity. So from -4 to positive infinity, we have got our graph concaving up. So this is correct. This is the right pattern. Meaning that for the second part, -infinity to -4, we are going to draw a concaving down pattern. So let's draw the second part, which is concaving down parabola. So that is how your graph will look like. That is the answer for this problem.